Hello, it's time to place some dominoes. We'll play pips today, starting with the easy puzzle. It looks like we've fallen into a pattern here where the easy puzzle is by the editor Ian Livengood, and then medium and hard by Rodolfo Kirchen. I wonder if it seems like that's been true at least the last few days. Anyway, we'll start with the easy puzzle. Let's start solving, shall we? Okay, we need 3 of something. We need a 2 down there. Of what do we have 3? We have 3 ones, so I think that means a double 1 needs to be here. And that would also require the other 1 to point down this way. We need 2 of something, which looks like it'll be zeros, so we've got those zeros here. And finally, this 2 sends the 5 into the void. There we go. Let's try medium. Okay, this is an interesting little area over here. So we'll need something pointing into the 3, something else pointing into the 5, and then the 2 pointing up into that 6 region. Oh, we only do have 1, 2, so actually it has to be this, which means there needs to be a 6 here. And we need something fully completing an 8 in a single domino, which must be double 4. Nothing else will work. We also need a 4. Let's see. Oh, we need a 3. We only have 1 3. So that goes here. I could have done that right at the beginning, actually. And we need a 5 that points down. That's fine. So the 7 will comprise 6 and 1. So I think that means the 1 needs to go here. Well, no, I guess that's not true. I guess we could waste that 6. Well, yeah, the 6 will be wasted either way. I guess it doesn't make any difference. Either way, no, actually it might make a difference because we can bridge the 6, 4 here, put a 6 here, and then send our zeros into the void. There we go. There might have been a slightly different way to do that, but anyway, that was how that went. Let's get on to the hard. See how this one treats us today. It looks like we've got an 8 illustrated in the grid, as we often have alphanumeric characters illustrated. Okay, we've got a 12, which needs 2 6s. We don't have a single domino that contains 2 6s, which means they'll both be bridging out. But what we don't know is whether one of the 6s points down into that equivalence region or points across into this other equivalence region. Either way, it's something we need 2 of. But I think that is true of everything that 6 connects to, so it's not yet useful. We have a 1 here. Is it possible for the 1 to point up? Yes, it is, because we have a 4, a 5, and a 6, all of which can be used to make a 10. We have a 3 here. That's not useful yet, I don't think. What do we have 4? Let's see. We have 4 1s. We would need 5 1s because there's also a numerated 1. We do have 5 1s. We have there might not be very many things we have 4 of. Let's see. We have 4 4s. Is it just 4s or 1s? Are those our only possibilities for this? Oh, and we need a double of it as well, which we have of both 4s and 1s. That would have been an easier way to look, that it needs a double. Interesting. How do I get started on this? Do I think either 4s or 1s is more constrained than the other? I think 1s might be harder to put elsewhere in the grid because they can never overlap into, say, an 8 cage or a 10 cage or a 12 cage, whereas the 4s could overlap into at least 8s and 10s. So what does that tell me? That tells me it would be slightly more difficult to complete the puzzle if we allocate most of our 4s to the equivalence region. It's not a deduction, it's just a sort of broad observation. I don't know that it necessarily means much yet. Okay, I don't think I've found the way into this. What are the ways we can make 8s? We could obviously we could use double 4, we could use 5 3, or we could use 2 6, and we have to do that 3 times. I don't know that that's hugely useful. I wonder if I should just start trying something and see what happens. Is there anything that only has, say, 2 possibilities? That 12 region maybe is what I should be looking at. Well, okay, the one at top must point over into the 8. That at least we know. The lower digit in the 12 region can point horizontally or vertically, but the one at top must point into the 8, which means it can't be this 6, 0. It cannot be this 6. Here, this is where I should have started. I should have started this way immediately. We can put that in. That goes right in. Sorry about that. Yeah. So that means we need another 4 in the 8. So this is immediately constraining the 4s. We still have enough 4s. We still have, we'll still have 4 left even after using another one. So it doesn't rule it out of that L-shaped equivalence region. But let's see. So 4, 0, if we used that, it could not point across. It would have to point down, which would then mean we'd need a 0, 6. I mean, that is a bit constraining, but it works. We'd then need the 10 to be self-contained, though, and that actually is not possible because we'd need a double 5 or a 6, 4. We don't have either of those. So actually that isn't true. So this 8 region is not completed with a 4, 0. The problem is we have so many 4s. What if it were a double 4? It couldn't go down because then we'd need a 4, 6. We've already used our 4, 6. So it would have to go across into the 10. Then we would need another 6 here, which could be this 6, 1 pointing down. But if it were that, we would then need, I don't think it could be this, because then we would need a double in this equivalence region, which would have to be a double 1, and then we'd have used all of our possibilities for how to make that 4-sized equivalence region. So that's actually not possible. Could it go across this way? We'd then need a 1. No, then it would need a 1, 6, and we've already just used our only 1, 6. So actually, that couldn't be a 6, 1 either. Interesting. It is a bit constrained. I think that means it's impossible. I think this double 4 is impossible, which is good. So I wonder if it's going to be impossible to do anything going across. Could it be 4, 5? Then we could do a 5, 1, in which case we'd have to use one of our doubles here, but we have both of them left. That might not be a problem. Although, actually, it might still be a problem. It would have to be double 1, because if it were double 4s, we wouldn't have enough 4s or 1s to make that bottom region down there, I don't think. So it would have to be double 1. Then we'd have to put 4s in the equivalence region down there. We'd have exactly enough to do it. Is that a problem? I'm not sure. We'd also need a 6 pointing down. For a 6 pointing down, we don't have a 0, 3, so it'd have to be 0, 4, which we do have. Okay, I'm getting pretty far afield in my guessing here. This is going farther into the guessing than I would like to have to do. I don't know. We'll just play it out and see what happens. This would have to be 3, 5, because 3, 2 we don't have a 6 to finish making that. So this would then have to be a 5. No, this breaks. Yeah, this is broken. Because then we'd need a 5. The only thing we could do here is a 5, 0 pointing down there. Okay, yeah, that breaks. So then this could be a 6, 1, I guess. That's the other way that this would work. Then we'd need a 1, 4 here, which actually is kind of what I would want it to be. This stuff feels like it could actually work in theory, because we could go 3, 5 here, 3, 2 here, 6, 0 here, and then we have zeros bridging these. Yeah, this actually does work. This works. Sorry, that was not a very rigorous solve. Apologies for that. I didn't really ever quite catch on to the most elegant method of narrowing these down. I mean, I found the starting point, but it wasn't a very elegant solve from that point on. Anyway, there we go. Those were the pips. Back tomorrow. Bye for now.